നമസ്കാരം, എല്ലാവർക്കും സ്വാഗതം. നമ്മളിന്ന് ട്രപ്പിസോയിഡൽ റൂളാണ് ഡിസ്കസ് ചെയ്യുന്നത്. നമുക്കറിയാം നമ്മളുടെ ടോപ്പിക് ഇതാണ്, ന്യൂമറിക്കൽ ഇൻ്റഗ്രേഷൻ ആണ്. ന്യൂമറിക്കൽ ഇൻ്റഗ്രേഷനിലെ ട്രപ്പിസോയിഡൽ റൂൾ എന്ന ഭാഗമാണ് നമ്മളിന്ന് ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. So in the last session we derived formula for numerical integration using Newton's forward difference interpolation. So let's recall the formula. The formula is this: the integral is equal to nh into y0 plus n by 2 delta y0 plus n into 2n minus 3 by 12 into delta square y0 plus etc. Alright. ഇവിടെ n എന്ന് പറയുന്നത് നമ്പർ ഓഫ് സബ് ഇൻട്രവൽസ് ആണ്. h എന്ന് പറയുന്നത് രണ്ട് സബ് ഇൻട്രവലുകൾക്കിടയിലുള്ള ദൂരമാണ്. y0 എന്ന് പറയുന്നത് ഫസ്റ്റ് ടാബുലേറ്റഡ് പോയിന്റ് ആണ്. ഡെൽറ്റ y0 ഈസ് ദ ഫസ്റ്റ് ഡിഫറൻസസിലെ ആദ്യത്തെ പോയിന്റ് ആണ്. ദാറ്റ് ഈസ് y1 മൈനസ് y0, so on and so forth. So in the present case we are going to make a substitution that n is equal to 1. So n equal to 1 means you have only the boundaries, 0th point and first point. Okay, so since for 2 points the second and higher order derivative differences will vanish. We have only 2 points, say x0 y0 and x1 y1. Then you can find out only the first difference. Alright, so due to that reason all the terms containing higher differences, delta squares, delta cube, etc. vanishes. So with that substitution we will get the integral as h into, because n is 1 into h, that is h, then y0 plus n in the center 1, so half delta y0. So this is the case. So that means you are using an interpolating polynomial to connect two given points. Obviously you can have a polynomial of degree 1. That means you are actually joining the boundary points using a straight line. So our interpolation is basically a straight line fitting. Correct. Now what we do is we now write the definite integral as I is equal to, this is the required integral. So we are supposed to calculate the integral y dx from x0 to xn. To calculate or evaluate this definite integral, I am going to split this definite integral into n small definite integrals. That is integral from x0 to x1 y dx, then from x1 to x2, then from x2 to x3, etc. xn minus 1 to xn y dx. So we split that integral into n sub intervals. Okay, and the point to be noticed is this: we are actually finding the integral between two adjacent given data points, x0 x1 or x1 x2, etc. So that means we are actually replacing every subinterval with a straight line, or simply speaking our interpolation is linear interpolation between two consecutive data points. So we'll look into the situation. So let us consider this as the x-axis, this is our y-axis. Now these are the points. This is first point, x0 y0, this is x1 y1, etc. We have several points. Now what we do is we are going to join, in order to approximate the function, we will just join this point with this point, then this point with this point, this one with this one, so on and so forth. So this way we just interpolate the given function like this. So this is the case of trapezoidal rule. Now what we are going to do is we are going to find the integral from this point to this point, then from this point to this point, from this point to this point, അങ്ങനെ എല്ലാ intervalsലും നമ്മൾ എല്ലാ sub intervalsലും നമ്മൾ integral evaluate ചെയ്യും. So that's the idea. Okay, now we will first consider the first sub interval, which is defined between x0 y0 and x1 y1. Okay, x0 y0 and x1 y1. So we calculate the first difference Please note that we can calculate only the first difference. Delta y0 is equal to y1 minus y0. This data minus this data will give you the first difference, first forward difference. So from this we can calculate the integral from x0 to x1. So we have the formula for the integral as h into y0 plus half delta y0. So h into here y0, the first data point is y0, so it's y0 plus half into delta y0, that is y1 minus y0. Upon simplification you will get it as h by 2 into y0 plus y1, because you have 1 y0 here and minus half y0, so full y0 minus half y0 is just half y0, and you have half y1, so h by 2 into y0 plus y1. That's very simple. Now the next interval, that is from x1 y1 to x2 y2. So here our first data point is y1, second y value is y2. Now we will find the difference, this one minus this one, so that is y2 minus y1. Now we are going to evaluate the integral from x1 to x2. So the basic formula is h into y0 plus half delta y0. So that is equal to, the first y value is here y1, okay, or you may get confused, the zeroth item is y1, so instead of y0 you will have y1, and then you have to calculate half into delta y0, the zeroth difference. What is the zeroth difference? This quantity minus this quantity, that is y2 minus y1. So upon simplification you will get it as h by 2 into y1 minus y2. Sometimes you may get confused, instead of y0 I am substituting y1, and instead of delta y0 I am substituting y2 minus y1. Why? The idea is very simple. Just assume that here it is some 3 and here it is 5. Then what is the first difference? 5 minus 2. If it is some a here and b here, then it is b minus 2. Correct. So if it is y2 and y1, obviously it is y2 minus y1. That's it. Okay. Now etc. Similarly we will calculate in every subinterval, and the last subinterval is xn minus 1, yn minus 1 and xn yn. Last subinterval. അപ്പോൾ xn yn നും തൊട്ടുപുറകിലുള്ള xn minus 1 yn minus 1 ഈ രണ്ട് പോയിന്റുകൾക്കിടയിലുള്ള ഇന്റഗ്രൽ ഇവാലുവേറ്റ് ചെയ്യാൻ പോവാണ്. സോ ഇവിടെ നമ്മൾ ഡിഫറൻസ് കാൽക്കുലേറ്റ് ചെയ്യാൻ പോവാണ്. The difference is this thing, this quantity minus this quantity. So that is delta y0 is equal to yn minus 1. So from this I can calculate the definite integral as integral xn minus 1 to xn y dx equal to basic formula h into y0 plus half delta y0. That's equal to h into, what is the first data point? It is yn minus 1. So yn minus 1. Then delta y0, the first difference, that is yn minus 1. Yn minus yn minus 1. Alright. So upon simplifying, you will get us h by 2 into yn minus 1 minus yn. Sorry, yn minus 1 plus yn. Now, to get the total integral, we need to find the sum of all these integrals. Integral in the first subinterval, integral in the second subinterval, etc. in the last subinterval. So we are going to find the sum of everything. So finding sum, you will get h by 2 into y0 plus y1 plus h by 2 into y1 plus y2, etc. So h by 2 is a common factor. I can take it outside. Then y0 plus y1 plus y1 plus y2. The next time will be obviously y2 plus y3, etc. yn minus 1 plus yn. So you can simplify that. H by 2 into, you have only one y0 and only one yn. So all other quantities, y1 for instance, you will have one y1 here, one y1 here. You will have two y1. Then one y2 here. The next time is y2 plus y3. So there are two y2s. So 2y2 plus etc. 2 into yn minus 1. Okay. So y0 plus 2 into y1 plus y2 plus etc. plus yn minus 1 plus yn, because you have only one yn. So this will give you the integral. Correct. So now we will try one simple example. So the example is this. You are given 5 plus 1, that is 6 points. That means your function from 1 to 2 is divided into 5 equal subintervals. So the points are this. At 1 the function value is 3, then at 1.2 the function value is 4.32, etc. At 2 it's 12. Suppose you are supposed to calculate the integral y dx from 1 to 2. So that's a problem. Now we have the formula I is equal to h by 2 into y0 plus 2 into y1 plus y2 plus etc. plus yn minus 1 plus yn. Alright. Now what is h? H is the difference between any two consecutive x points. So here it is 1.2, this is 1, so the difference is 0.2. Then y0 is 3, y1 is 4.32, y2 is 5.88, etc. So I am substituting everything. Then plus yn, so that is 12. Please note that 2 into y1 plus etc. plus yn minus 1. That is the first data point, last data point ഒരു പ്രാവശ്യം sum ചെയ്യുന്നുള്ളൂ, but all other y values are summed twice. Okay. Then upon simplifying you will get the result as 7.02. Okay, but actually I generated this table from this function 3x square. Alright, you can verify that when x is equal to 1, then 3 into 1 square, that is 3. When x is equal to 2, 3 into 2 square, that is 3 into 4, that is 12. So this is the function. So upon integration you must get 3 is a constant, take outside, then x square, upon integrating you will get x cube by 3. Then substituting the limit you will get it as 7. So we expected if the method is perfectly correct you will get 7. But here as we already explained, this is a quadratic function where we interpolated between two consecutive intervals with the linear function, straight lines. Please remember that. അപ്പോൾ നമ്മൾ ഫംഗ്ഷൻ ഇൻ്റർപോളേറ്റ് ചെയ്തത് ഒരു ലീനിയർ ഫംഗ്ഷൻ കൊണ്ടായിരുന്നു, but here the function is quadratic, so naturally you cannot expect the correct integral. So we are getting a very closer result. That's it. Okay. അപ്പോൾ ഇവിടെ നമ്മൾ x square ഉള്ളതുകൊണ്ട് ഒരു quadratic function ആയതുകൊണ്ടാണ് നമുക്ക് exact value കിട്ടായിരുന്നത്. If it is a linear function, definitely we will get the result, exact result. All right. Thank you. ഇനി അടുത്ത സെഷനിൽ നമ്മൾ അടുത്ത ന്യൂമറിക്കൽ ഇൻ്റഗ്രേഷൻ ടെക്നിക്കായ സിംപ്സൺസ് റൂൾ ഡിസ്കസ് ചെയ്യും.